Across the land and in our deep seas, an army of people is working flat out to meet our energy demands.
We are fundamentally splitting the atom.
This is the story of those at the sharp end of the power industry. Energy production is changing. In this series, we find out how it works.
When you are trying to achieve 2,000ths of an inch on something that weighs 80 or 90 tonnes, that's what sorts the men from the boys.
From nuclear power and offshore gas, to biomass and harnessing the wind. It's energy production on an epic scale.
Can't believe I'm stood on the top of a wind turbine.
In this episode, I meet the men and women building Britain's biggest offshore wind farm.
This is how our power is made.
A green energy revolution is underway and it's taking shape in the North Sea. Massive offshore wind turbines are providing an increasing amount of our energy. But what does it take to build a wind farm? And who are the people who make it happen? I'm Keely Donovan, and like many people, I know little of where my energy comes from. So it's time to immerse myself in the world of offshore wind. But the story doesn't start out here. It's early morning in Aberdeen, and I'm about to do something I'm not really looking forward to. Anyone who works in the offshore industry has to undergo rigorous training. Safety is everything, and that includes knowing what to do if your helicopter is forced to make an emergency landing. It means I'll have to escape from a pretend helicopter that's turned upside down in the water.
So basically, if everyone else has got to do it, then I do too.
Brace! Brace! Brace!
This pool isn't the raging North Sea, but I'm about to learn survival skills that might just save my life. I hope that's a big enough breath.
Well, I survived. Just. It's a really strange sensation in there. It feels like you're in a washing machine being spun around. And even though it wasn't as bad as I thought it was going to be, I definitely would not want to do that in the North Sea.
A few weeks later, with the training still fresh in my mind, I'm at Humberside Airport near Grimsby. I'm heading for the Hornsey 1 wind farm that's being built by the Danish energy company Ørsted. Hornsey 1 is 75 miles off the Yorkshire coast, and as of 2020, it's the world's biggest offshore wind farm, nearly twice the size of the previous largest. It's a 45-minute helicopter ride, which takes me over the factory in Hull that manufactures the turbine blades. Soon we're out at sea, passing the boats that take the blades to what's essentially a huge offshore construction site. This is where many of Hornsey 1's workers live. It's a jack-up vessel with metal legs that are driven into the seabed to lift it above the water. And everywhere you look, there are turbines. They're mightily impressive, 190 metres tall from sea level to the tip of the blade.
To put that into some kind of perspective, If you were on the top of one of these things, you'd be looking down at other giant structures like Blackpool Tower or the Humber Bridge.
The blades are huge too. Each one weighs 26 tonnes and is 75 metres long, which is as large as the wingspan of the world's biggest passenger aircraft. I'm keen on taking a closer look at the turbine, but to get to one means getting off the jack-up vessel and onto another boat. But out in the North Sea, that's less than straightforward. Many offshore workers regularly take this journey, and it starts by clambering down a ladder. You're attached by a safety line and have a harness, but the sea's swell tests your nerves. There are 174 turbines in the Hornsey 1 field, in an area of more than 400 square kilometres. You could easily fit the island of Malta inside, or, if you like, more than 58,000 football pitches. These are the crew vessels. They're like taxis taking staff to the turbines, and Ørsted construction manager Gordon Pope is going to help me understand how these giant structures operate.
It's absolutely massive, isn't it?
It's absolutely huge, especially when you're underneath it and you can tell the scale of it. It's over 180 metres tall, which makes it taller than the Gherkin in London, and its wingspan is over 152 metres, and what that means it's wider than the London Eye.
The building of Hornsey 1 has pushed the limits of what was previously thought possible.
We're obviously over 70 miles from shore. We have support vessels like we're standing on to crew transfer people around. We're trying to do that over such a wide area. When we started this project, we kind of jokingly called it a man in the moon project for Ørsted and the industry.
The blades for these huge turbines are manufactured in Hull by Siemens Gamesa. Each one is handmade from balsa wood, fiberglass and resin. They're so big, they're wide enough at the base to accommodate an adult elephant. They're brought out to Hornsey 1 wind farm by boat and are assembled on site. It's a complicated process. Firstly, huge monopiles weighing 800 tonnes are driven into the seabed. Then the turbines are bolted on top, with the blades added at the end. Each turbine can produce 7 megawatts of energy, making Hornsey 1 the first wind farm in the world to generate more than 1 gigawatt of power. The turbines are super efficient. Just one rotation of the blades makes enough electricity to power a house for 24 hours. So, how do they work? At the top of the turbine is a streamlined casing called the nacelle. This contains the machinery that converts the wind to electricity. The nacelle is able to pivot so the blades make maximum use of the breeze. The wind pushes the blades, which then slowly turn a rotor which is connected to the main shaft. This drives the electrical generator, which makes electricity by spinning magnets past coils of wire. Even the lightest gust will get the rotor and blades spinning. The turbine is effectively self-starting. This part of the North Sea was chosen because of its strong breezes. Optimum wind speed for these turbines is just over 30 miles per hour. And to prevent damage, sensors will automatically turn them off when it exceeds 53 miles per hour. They're remarkable bits of kit, and engineers get them up and running in double quick time.
On this site, averagely, we've been from moving into position and then leaving the position, so a turbine's fully erect, it's taken around 16 hours. What happens after that is a crew come in with another vessel and they work on the turbine to commission it. All of our turbines are already live, so they're already connected back to our substation, so they can get it working in yet another 16 hours.
So feasibly, in a day or two, that'll be working?
We're always a day and a half just now. We're aiming to get under a day on this site, but currently, yeah, it's taking just 2 sets of 16 hours and you start producing electricity to the grid.
I'm impressed with that. That's pretty quick, that.
Yeah.
The turbines feed their power to one of 3 offshore substations, and it's from here that electricity is sent back to the mainland. The substation transforms the power from 34,000 to 220,000 volts, and it gets back to the UK on a series of underwater cables, which, if put end to end, would stretch from London to Newcastle. It's impressive stuff, especially when you consider what a hostile environment the North Sea can be, as turbine technician Simon Stevenson knows only too well.
That is a J-tube, and the cable's going down there into a trench upon which boulders have been covering it. So it obviously needs to be armoured. They're very strong, protected cables, going for 80 miles, and there's never a loss of power, so that when you go home at night, switch on the kettle, the light comes on, the water's boiling.
I know we're in the middle of the North Sea, but it is summer and it's blowing a gale. Does the weather affect how you work here?
Well, this site has been chosen specifically. We want wind, the power's being made, and we're happy.
But you don't just get the wind, do you? You get the rain as well. That must make working out here really hard.
We just keep operating, we put on different clothing. The only thing that will stop us would be lightning. And if there's lightning, we all take shelter until the lightning threat passes, put on our raincoats and get back out and go back to work.
Over in Ørsted's East Coast control room, they're also watching out for bad weather. These turbines are very good electrical conductors, so if a storm's brewing, a lightning tracker makes sure everyone stays safe.
If lightning strikes within 50 kilometres of a site, it will rumble with thunder. If it strikes within 25 kilometres of a wind farm, it will actually do a massive clap of lightning in the office.
Louise Crooks is part of a team that's constantly monitoring the safety of Ørsted's turbine workers.
It actually feels like we're in a thunderstorm, doesn't it? So what happens when you hear that then?
As soon as that happens, we put out an all stations alert to the field to let them know there's lightning in the 25 zone and send all of technicians to safe zones. You can sail out in the morning and it's flat calm and it's a lovely day, and within a few hours a massive storm is coming across and lightning's going off left, right and centre. We're constantly tracking it. We've got radars showing the rain that's coming. If we've got lightning risks, we're aware of it. We've got wave buoys showing the sea state in the field, and on all our systems we can see what the wind speeds are on every turbine.
But it's pretty serious stuff, isn't it? If you've got thunder and lightning out there, presumably lots of stuff has to stop.
Yeah, as soon as there is lightning in the field, work stops.
They're a tough lot out here, and they're well looked after, especially when it comes to food. It's restaurant quality, and with more than 100 folk on board, there are challenges for the chefs.
We're just about to feed the day crew who have just finishing their shift, which is probably about 107 tonight.
They're hungry, aren't they, when they come in?
Very hungry, especially if they've been out to sea in the wind farm itself, on the CTVs. All have had all day is a packed lunch, which is just a sandwich, sausage roll, a Mars bar and a can of Coke. That's it. So they come back and they're good eaters. Very good eaters.
I can imagine they are. I'm seeing a few of them.
Your little bit of pressure is, do you have enough food?
And do you have the right food? What goes down well?
Fajitas. Love fajitas. You tried to make it like a restaurant.
So it's a different thing every day?
Yes. Every day is a different meal, and there's 4 meals a day.
Carl's no stranger to an offshore life. He's spent big chunks of time working on rigs off the West African coast, a long way from home in the northeast of England.
Does it take a toll on family life, being away from the family for such long periods of time?
It does. When I first started, my youngest was 5-year-old. She's now 19. So basically I've missed 7.5 years of her life.
Is that how it feels?
Yeah. Sometimes it does.
Doesn't make up for it that you're then home for long periods of time?
That's the best bit. When you're at home, you have the 4 weeks where you can spend as much time with them as possible and do what you want with them.
Despite the drawbacks, it's not a life that Carl would readily swap.
When people ask what do you do, you say I'm a head chef offshore. Oh wow!
You're proud of it?
I'm proud. Yeah, I'm proud of it. So.
Should we get these oranges out?
Yes. Yeah. And watch how fast they go.
Britain's going through a renewable energy boom, and one of its epicentres is the former fishing town of Grimsby. It's here that Ørsted has the world's largest offshore operations and maintenance facility, and it's all very high-tech. It's been built at a cost of £14 million under the shadow of Grimsby's dock tower. It's a base for vessels picking up supplies for the 6-hour journey to Hornsey 1, and for Ørsted boss Darren Ramshaw, who grew up not far away, it's a proud moment.
Got our operations teams that go out there, service our wind farms on a day-to-day basis. Just 350 people employed here, all living within about an hour's drive. 80% of the people about an hour's drive away from here. So it's just a phenomenal place. It's the biggest in the world, and it's just a rejuvenation of Grimsby. It's fantastic.
And why Grimsby?
It's got the facilities, it's got the port, and clearly the wind farms out there that you can see just in the background. It's got the infrastructure, so here it made sense for the facilities, what we've got, and we've got talented people in the area that it's just a good rejuvenation.
This expanding energy business is having a big impact. Not far from Grimsby, there are 2 huge electrical substations. One is complete, the other is being built. They'll receive power from the wind farms, which comes via cables that are buried under miles of farmland. The substations transform the voltage and send it onto the national grid. And the construction work is planned with military precision.
So this is a planning meeting with a difference. Every day the team meet and they use this model, which is a 50th of the size of the site, to plan what's going on that day. I've never seen anything like it.
It helps staff to visualise the site. And as construction manager Richard Swan told me, some solutions to problems are simple but rather clever.
One of the largest items that will get delivered is the transformers, which are weighing around 250 tonne and are delivered at the docks in Immingham. They're brought to site on a multi-axle tractor-trailer unit, which will help distribute the weight as it travels on the local roads around here. And then once they're on site, they're moved into final position by what we call skidding, which is essentially we set up 2 little tracks and we use pistons to slide the transformer across its position. And just to help it on its way, we use a little bit of washing up liquid just to make sure it slides nice and easy across.
So you're sliding a 250-tonne transformer with some washing up liquid?
Sometimes some difficult tasks just need some ingenious solutions.
The inside of these substations is like stepping into another world. This high-tech kit takes electricity from Hornsey 1.
When the power arrives here at the onshore substation in North Killingholme, the power's stepped up by some transformers. We call them supergrid transformers, and that steps up the voltage from 220,000 volts to 400,000 volts that we're actually stood in front of here now.
So 400,000 volts, that's what's in these pipes?
That's right. So when you think about a home, you have a highest voltage of 230 volts AC. This is 400,000 volts. So this is the highest voltage that you will actually get on any transmission system in the UK.
Daniel Katz is one of Ørsted's senior engineers, who's played his part in Britain's renewable energy bonanza.
You've been working in this industry for quite a while now. Are things just getting bigger and bigger?
Yeah, I mean, even by Ørsted's standard, Hornsey 1 is groundbreaking in its nature. It's a huge infrastructure project. This is my 8th wind farm I've worked on, and each wind farm's got progressively larger and larger. The turbines are getting bigger and bigger. They each have a higher capacity. Yeah, it's becoming much bigger, and obviously much more of an efficient and low cost method of producing power.
So what's it like working in the renewables industry?
Fantastic. I mean, I often pinch myself to say that I get paid for this work, but It's really, really good. This is providing clean power to well over 1 million homes in the UK, which is a fantastic thing to be involved in.
I'm going to think of this place every time I switch my kettle on for a cup of tea.
Me too, yeah. And a million other people as well.
Yeah.
I've set my eye on getting to the top of an offshore turbine. So I'm back in the North Sea and I'm hitching a ride on the Edda Mistral. She's Ørsted's service operation vessel and plays a crucial role in moving staff around Hornsey 1. And she's state-of-the-art.
We're just about to transfer from the substation onto this boat, and we're going to do it via this telescopic platform. Now, this has revolutionised the way that crews move around from vessel to vessel, because no matter what the state of the ocean is, this thing compensates and stays steady. And we can go now because there's the green light.
The Edda Mistral can carry up to 40 wind turbine technicians and has a crew of 20. And as befits a ship that's kitted out to the same standard as a cruise liner, she's rather plush inside.
The ship is designed to be comfort class 2, which is very, very quiet, so the technicians aren't disturbed by noise throughout the night or the day. We have rubber-mounted tunnel thrusters, which also reduces, and double glazing, basically inside windows, also help in the lower decks where they are. So it's a pleasure to drive her, and it's a pleasure to work in this environment. After 30 years of oil and gas, this is the way to go now, renewables.
Barry Roberts is the boat's captain. He's spent almost 5 decades at sea.
You must have seen some terrible weather out here.
Well, up in the north, I spent a long time west of Shetland, which is extreme, up to maybe 14 metres significant waves, which is about 50 feet for maybe a week or two. But you get used to it, and the ship's safe. You know how to shellac, so once you've been there a few years, it's easy.
There's no way you'd be working on these, though, in those kind of conditions?
Oh, gosh, no. We know the limits of the gangway, which is what governs everything. And when we get near that, we do have good forecasting. So as we approach that, we know we can get the guys off the turbine. We do not want to lead them on a turbine.
Everything is aimed at making the working day as comfortable as possible.
Oh! It's like a big toy. I'd never get any work done.
It's all a big toy.
You seem very relaxed for somebody who's probably not always working in a relaxed environment.
You have to be.
We're safe in your hands.
I hope so, yes. It's a safe ship, it's a safe environment, and that's how we keep it.
Okay.
Vessels like the Edda Mistral are transforming offshore working. The telescopic platform means staff can walk to work. It makes it much easier for the turbine technicians, because out here the sea always has to be respected.
It's a really good ship. I mean, we had 5 metres out here the other day, and we literally turned stern to, and the waves just came and broke against the stern, and we were just sat here.
Really?
And it moved a little bit up and down, but it was really, really comfortable.
Rebecca Goff is the duty operations manager on the Edda Mistral. She leads a team responsible for making big decisions, who goes where, and if it's safe for them to go out at all.
What's the weather like for tomorrow then?
So the weather tomorrow, we've got a low significant wave height. So we had a little blip that came through the other day, and then you can see there, so the significant is 1.3 metres, and then it's dropping throughout the week. Because we're a long way offshore, we've got a big swell out here, which is consistent, so we'd need to take that into consideration as well. So we're not just looking at the total sea, we've got to look at the swell, the wind, the waves.
And there's plenty on my mind as I gear up for what could be a bit of a physical challenge. I'm going to attempt what many staff have to do in their daily work, and that's get to the top of a turbine. It's going to be a tall order.
So here I am in the wind turbine for the first time, but that's where I want to go, up there. But I think I've got a few rungs of this ladder to climb.
I'm wearing a harness, and there's a device that will stop me falling off the ladder if I lose my footing. But it already feels like hard graft. That's the first bit of climbing done. Thankfully, there's a lift to take me most of the way to the top.
It's tight in here. Oh. This is probably a good time to mention that I'm claustrophobic.
Oh, yeah?
I didn't fancy all those steps though. So we're in the lift and we're going 100 metres up to another level near the top of the turbine, and we're all secured in, quite noisy, quite a small space. Here we are on the top floor. Right, let's just unclip this. There you go. Right, we've made it. Just a few more steps to climb.
Some people make ladder climbing look incredibly easy. I'm not one of them.
I won't be going that quick, I don't think. Yep.
And now I can see what makes these turbines so incredible.
Just look at it in here. All these nuts and bolts, just a snapshot of the engineering that's gone into one of these things. So I've made it up to the yaw deck. Everything from this part downwards is the tower, and everything from this part upwards is the head of the wind turbine. There's a very slight sway. Goodness knows what it's like on a really windy day, and I'm not even right at the top yet. Coming up!
And all that climbing and effort is about to pay off.
Wow! Look at this! I can't believe I'm stood on the top of a wind turbine. Just look at those blades. There's just turbines everywhere you look. And what makes it even more incredible is knowing the hard work and the journey of one of these turbines to get it to this stage. This is amazing.
As workplaces go, this has got to be up there with the very best. Offshore wind meets 10% of our energy needs, and that figure is only going to increase. Hornsey 1 is now fully operational, and Ørsted will soon bring more wind farms to the Yorkshire coast with Hornsey 2, with plans for Hornsey 3 and 4 to follow. While ever the wind blows, these huge structures will be doing their bit in keeping Britain fully powered.